We can examine the question of how planes fly under 3 headings. 1. Lift generation. The wings of an airplane are designed to generate lift. The upper surface of the wing is curved while the lower surface is flatter. When air flows over the curved surface of the wing, it has to travel a greater distance over the top of the wing than it does underneath the wing. This creates a region of lower air pressure above the wing and a region of higher air pressure below the wing. According to Bernoulli's principle, the pressure of a fluid, in this case, air, decreases as its velocity increases. As a result, the lower pressure above the wing creates an upward force on the wing, which is the force of lift. The angle of attack is also important for lift generation. The angle of attack is the angle between the chord line, an imaginary line from the front to the back of the wing, and the direction of the incoming air. As the angle of attack increases, the lift generated by the wing also increases. However, at a certain angle of attack, known as the critical angle of attack, the airflow over the wing becomes turbulent and the wing stalls. This reduces lift and can lead to loss of control of the airplane. Therefore, pilots need to be aware of the critical angle of attack and avoid exceeding it during flight. 2. Thrust. Thrust is the force that moves an airplane forward through the air. The engines on an airplane provide the necessary thrust to move the airplane forward. Jet engines, for example, are located under the wings or at the rear of the fuselage and use the principle of Newton's third law: for every action, there is an equal and opposite reaction, to generate thrust. The engines expel a high-velocity jet of gases behind them, which propels the airplane forward. Propeller engines, on the other hand, use a rotating propeller to generate thrust. The amount of thrust required to keep an airplane in the air depends on various factors, such as the weight of the airplane, the altitude at which it is flying, and the speed at which it is traveling. During takeoff, the airplane needs a high amount of thrust to accelerate down the runway and lift off the ground. Once in flight, the amount of thrust required is less as the airplane can maintain its altitude with less power. 3. Control surfaces. The control surfaces on the wings and tail of an airplane are used to control its movement in the air. The ailerons, which are located on the trailing edge of the wings, are used to control the airplane's roll. By deflecting the ailerons upward on one wing and downward on the other, the airplane rolls in the direction of the upward deflected wing. The elevators, located on the tail of the airplane, control the pitch of the airplane. When the elevators are deflected upward, the nose of the airplane pitches up, causing the airplane to climb. When the elevators are deflected downward, the nose of the airplane pitches down, causing the airplane to descend. The rudder, which is also located on the tail of the airplane, controls the airplane's yaw. When the rudder is deflected to one side, the airplane turns in that direction. Pilots use the control surfaces in combination to control the airplane's flight, make it climb, descend, turn, or maintain a straight course. In summary, airplanes fly by generating lift using the wings, which requires forward motion and the correct angle of attack. The engines provide the necessary thrust to move the airplane forward, while the control surfaces on the wings and tail allow pilots to control the airplane's flight. Write your questions in the comments. See you in the next video.